Hello, my name is William Gorman, and today I'm going to be doing my chemistry ISP presentation, and my topic is lead storage batteries. Lead storage batteries are batteries commonly found in cars that can be used to store high amounts of energy and release high currents in a short amount of time. They were designed in 1859 by Gaston Planté, and the design has not changed much except for the slight improvements made by Faraday. Lead storage batteries are able to be recharged and discharged many times. They contain lead, lead oxide, and sulfuric acid. They can go from receiving energy to discharging energy instantaneously, which is why they are so popular in today's society. Now I'm going to go on to the design of them. Originally, Planté's design consisted of positive and negative plates that were made of spirals of lead foil separated with a sheet of cloth and coiled up. This design caused the cells to have a low capacity and took a very long time to corrode the lead foils, creating lead dioxide on the plates and roughening them up to increase surface area. This meant improvements could be made, but Planté's plates are still used in some stationary applications where the plates are mechanically grooved to increase surface area. The more modern version of the lead storage battery, as you can see on your screen, was created by Camille Alphonse Farre. Each plate consists of a lead grid. The holes of the grid are filled with a paste of red lead and 33% dilute sulfuric acid. This porous paste allows the acid to react with the lead inside the plate, which increases the surface area. Once dry, the plates are stacked with suitable separators and inserted into the battery container. An odd number of plates is usually used, with one more negative plate than positive plate. Each alternate plate is connected. I'm going to go through the chemical reactions that occur within the battery. So the discharge chemical reaction first. When a lead storage battery discharges, both the positive and negative plate become lead the second sulfate. The electrolyte loses much of its dissolved sulfuric acid and becomes primarily water. The primary function of this process is to drive electrons from the negative plate back into the cell at the positive plate in the external circuit. Negative plate reaction is as follows. Positive plate reaction. And by combining these two reactions, one can determine the overall reaction, which you can see on your screen right now. The charge chemistry. Since the lead storage battery can be recharged, there is also a charge reaction. In the charged state, the battery contains negative plates of elemental lead and positive plates of lead the fourth oxide. These plates are in an electrolyte solution of approximately 4.2 mol per liter sulfuric acid. The primary function of this reaction is to forcibly remove electrons from the positive plates and the forcible introduction of them to the negative plate by the charging source. The negative and positive plate reactions are on your screen right now. And by combining these two reactions, we can see that the overall reaction is the reverse of the discharge reaction. Now I'm going to move on to the environmental impacts of lead storage batteries. Although the batteries are reliable, they have a limited life ranging from 3 years to 12 plus years depending on the manufacturing process of the battery. They are heavy to ship and contain toxic materials that require specific removal techniques at the end of their life. According to statistics, approximately 3 tons of waste batteries are produced each year, and production of lead storage batteries will only continue to rise with sustained and increased development of our economy. Lead storage batteries consist of electrolytes, lead and lead alloy grid, lead paste, and organics and plastics, which include lots of toxic, hazardous, flammable, and explosive substances that can easily create potential risk sources. The materials contained in lead storage batteries may bring about many pollution accidents such as fires, explosions, poisoning, and leaks that can contaminate environments and damage ecosystems. In conclusion, I would say lead storage batteries are a very viable source of alternative energy that are already being used in today's society in the form of electric wheelchairs, bikes, cars, and motorcycles. I think these will only become more popular as our economy continues to grow. Thanks for listening.